and welcome to the wind correction worksheet instructions. This is going to give you a visual for what's going on with that E6B of yours. You're going to need cardstock, old manila folder that is, scissors, a metric ruler, and a wee protractor. So let's get to it. Move this out of the way, and I'm going to get started. I notice my course is 300, wind is 260 at 36. So see, I have the advantage of rotating this card. I would have drawn my compass rose this way with 300 in the direction I'm traveling. Again, that's my true course. And I know that the wind, well, if I take the wind, it's coming from where? 260. That's 270, 240, 260. Just right around there. And you can see right away that the wind is coming from your left side. So we already know, that the wind correction angle is going to be to the left. We're going to demonstrate how much though. That'll be the hard part. Okay, the fun part. Let's get to this. But first I forgot to say, I'm using a scale on this entire operation. 1 millimeter is going to be equal to 1 knot. So what I mean by that, let's take this straight edge, your ruler. Now I'm going to put my metric ruler right there. I'm measuring this vector. This vector represents the true airspeed of the aircraft. So you've got to read it. That's 9 centimeters, also known as 90 millimeters. Let's see, and let me see, I see 6 and 8. It's between those two. I'm reading it as 97 millimeters, 97 knots. Now, because this point and this vector is measured at 97, that means anywhere along this arc is also 97. It is an arc on a circle. So let's move this out of the way. We don't need that for now. Move it right here for now. And let's get to the cutout part. That's the fun part. We're going to cut out a little triangle. Well, I can see here between 260 and 300, I can see a 40 degrees. The wind is coming at us 40 degrees off our port side. So let's take our protractor and we're going to measure this. I'm going to draw a ray. You've got to line up the vertex of the protractor with the edge of your cardboard. Now, be careful. The vertex on this protractor is right on this edge. Sometimes it's in there, sometimes it's in the middle. You've got to know your protractor. I'm counting the degrees, 10, 20, 30, 40 right there. And then I'm going to draw a ray. Now, you're probably wondering why a protractor and why not a plotter. Well, a plotter is, well, we're going to use that a little bit later on. Right now, you need to be able to use a protractor as well. This will help you with your high school math work. Let's move this out of the way. You've got 40 degrees marked off. And then I'm just going to use this ruler. I'm going to square it up like that. And I'm going to use that to make a right angle. It's not a Euclidean construction, but it gets the job done. And you pretty much got the idea that you have a right triangle right there. Okay? And let's see, I trace across. I've got this point here. And now I'm going to trim away. Take those scissors out and cut this piece out. What you have, you might want to write down 40 right there, 40 degrees. Make sure you don't lose track of which angle's the 40. And I can visualize what's happening. I've got this right triangle where this is going to be total wind. This is headwind. This is crosswind. Now you're saying I didn't size it correctly, and you're right. I find it more useful. Do this in 2 steps. Cut it out a little bit bigger, and now we're going to make sure we match it to our appropriate wind. Remember, wind is 36 knots. Well, that's 36 millimeters. So take your straight edge and line it up there. I see 30, 2, 4, 6. This 36 looks like it's about there. So I'm going to measure my wind out, and sure enough, there it is. It's 36 millimeters. Take my straight edge again. Now you're sliding it like this. Same thing, you can just kind of slide it so it looks parallel, or you can square it off the end there. Either way, you're sliding it up there, and you're going to, let's see, mark this triangle. Now that's the triangle that we're looking for. Now, again, take your scissors and trim away the rest of it. Now we're in business. See what we've got. We've got the triangle, which represents our wind. Our 36 represents our total wind. Our crosswind component would be here, and this would be our headwind component. You've already learned that earlier in the textbook, and you already know how to use a chart for that. But again, this is a visual demonstration, so we're going to proceed from here. Oh boy, what to do. A couple things to look at. Let's first take this and move it over here. Now, if I do that, if I line up the vertex with the tip of this arrow, what I'm representing is where my aircraft would end up. I'm flying this way, I'm flying this heading as my course, but I'm getting blown over to the side, and after 1 hour, I'm going to end up over there, off course, to the right. So that's no good. Instead, I'm imagining I'm going to take this triangle and I want to move it. This vertex right here has to be along the arc. So it's going to be right there. Remember, that's my little 40 degrees. When you've got this, take your tape. Didn't put that on the required list of materials, but you got the idea. Take that, your little cardstock, and tape it down onto your paper. And you're taping it. It should look like this. This vertex is on this arc, which is the 97 knot arc, and it should be lined up. This should be parallel here, or if you prefer to say perpendicular, like that. So this side right here, parallel to your course. Wow, now it's getting good. Now, intuitively, if I turned 40 degrees, I would not actually follow my true course. Instead, I'd fly directly into the wind. Instead, what I'm doing, and this really does work, I'm going to aim my airplane at this point. And if I fly, then I'm just going to track beautifully. Trust me, it works out. It's beautiful. So, how do we represent that? We're going to do it this way. Take your straight edge, suppose this one over here, and you're going to draw to there. That's the magic right here. And now, the angle that you formed here, well, I guess we can measure that. We need a protractor, I guess. Let's bring that protractor back. Now I could put my vertex there, rotate like this, and let me see, I've got 10 degrees, 11, 12. Boy, you're going to have to read really carefully. It's looking a bit like 15 there. I could also have produced it, gone around. How would I want to do this? I could do this several different ways. Yeah, I could line up this way. And I could read my angle over here. And I can see my 10. That's, see, 15's over there. It's looking a lot more like 14 the way I'm reading it. So, I think I'm going to turn 14 degrees to the left. That will be my wind correction angle. Protractor be gone. So now, well, we could figure out a couple more things here. I'm going to do a little bit of arithmetic. And for the heading, that's where I have to steer. It's going to be over here somewhere. Looks like it's going to be 286 because clearly I have to turn to the left. And if I'm turning to the left, I'm going to take 300 and I'm going to subtract my 14. And now, where does ground speed come into this? You know, on your E6B, you read the grommet. Well, here, you're going to do this. You're going to put your ruler again there. That's 60.24, lining up there. That's looking like 66 knots. Pretty slick, don't you think? Okay, that's. I think we're done with. Well, we're done with this demonstration. Except some of you want to see the trig. Always hearing, what about the trig? Now, again, let's move these out of the way. This is going to be tricky here. And again, remember your headwind component, your crosswind component of the wind. Okay, let's do the trig. You talked me into it. We first have to know something. That trig, oh, my airplane needs to get out of there. The function we're going to use is sine. And we know that SOHCAHTOA tells us that sine is the ratio of the opposite over the hypotenuse. Well, I'll move this out of the way. If I'm looking at the wind, I'm looking at this triangle first, right here. And I'm looking at looking at this side as being the opposite. It's opposite the 40 degrees. And the 36 millimeters, or 36 knots, is the hypotenuse. So again, I'm going to solve. I'm solving for this. You'll see why in a little bit. All right. I'm getting confused. I'm getting dizzy here with doing so much. I'm going to say that the sine of 40 is the crosswind. That's the opposite over the hypotenuse, which is 36. I can rearrange that, and therefore the crosswind is 36 times the sine of 40. Or you could have used your chart. Well, I could solve for that, but hang on to that thought. I'm just gonna hang on to that for a little bit. Move this out of the way. And now I'm going to think another way. I'm imagining a different right triangle where this is the hypotenuse, the 97 knots. And now the opposite is going to be this distance, and I should draw it. Well, I suppose I should draw it up here, right there. That's the distance I'm looking at as my opposite. So on this trig function, it's going to look like this. The sine of some angle, and I'm going to call this W for wind correction, is equal to the opposite over the hypotenuse. Well, the opposite is the crosswind. That's this right here. Oh, that's ugly. Let me get that out of the way. And the hypotenuse is the true airspeed. Remember, this arc is 97 knots all the way around. So, I want to know the angle. So I know that if the sine of W is crosswind over true airspeed, then the angle, our wind correction angle, is the inverse sine of crosswind over TAS. Let's do the substitution. Oh yeah, we can do this right here. I'm going to represent crosswind as this trig function. Yikes. Now all I got to do is crank through that. Are you ready? More than you bargained for? I don't think so. I think you're all good for it. I need a calculator first. Hey, here's one right here. First, let's find the crosswind component, and that's 36 times the sine of 40. 36 times 40 sine equals. So the crosswind component is about 23 knots. I look at this picture, yeah, that makes sense. About 23 knot component of crosswind. And now I'm going to take that and I'm going to divide that by 97, my true airspeed. And look at that, I've got some decimal. Who knows what that means? Well, I'll tell you what that means. That's the sine ratio of angle W, the wind correction angle right there. So what would we do? Of course, we would take the inverse sine, and heavens to Murgatroyds, look at that, 13.8. You can't beat that. And what did we come up with our protractor? We measured 14. I guess the only thing left to do is to do this on an E6B and see how they all compare. Well, this example will be different, and you'll see why shortly. But let's get down to the basics. I'm going to measure, I'm measuring this vector here. That's my true airspeed. I'm lining it up there. And let me see, 7 or 70. And this is 80 right back here. That's looking like, well, 78 to me. 78 millimeters or 78 knots. All right, got that started. That was easy enough. Now, the true course is already dialed in here. Already got the compass rose turned to 253. Again, to visualize here. It's not really our DG or anything. I'm looking now at my wind, 052. Now you're going to notice something different. If this is wind, see, wait a minute, where's 052? Oh yeah, it's all the way down there. And you see what that means. This is a tailwind. So you're going to be pushed from behind. And what angle do I want? Well, the angle I want you to imagine is this angle right here. Now, if I take the reciprocal of 253, I've got 73, and I take away the 52, or 052 for the direction of wind, I've got a 21-degree angle. In other words, the wind is, well, it's not exactly a tailwind. It's 21 degrees off to the right side, quartering tailwind. So that'll help us visualize. Now let's get to drawing. I'm going to need my protractor, right there. I'm going to count out 10, 20, and one wee one there for 21. And line up your straight edge and draw that 21-degree ray in there. Now let's see, suppose I can move this protractor out of the way for now. And it's time to do some trimming. Well, what we did before, remember we took the straight edge, we're just lining it up just so we can, so I can draw this and cut away and make ourselves a little triangle out of our cardboard. Now that's very good, except we need one where the hypotenuse is 32. After all, this represents our total wind. So I'm going to turn this, line that up with 32, and measure it out. Measures out there. So let's measure our 32 knots. That looks good. And then, of course, same thing. I'm going to take my straight edge and I'm going to line it up like this, and I'm going to trim this again. All right, I just did that. You can see that parallel or square with the corner. And now I can trim it away. And that little triangle is going to represent my wind. Now, same as before, this is the resultant. That's my total wind, headwind, or in this case, tailwind component, and crosswind component. Now, if I were to take this and move this over here, that wouldn't be exactly right, because as you can see, I would end up getting blown over here. I get blown off course. So instead, I'm going to take this. I'm going to move it this way. Yeah, just like that. I want you to line up this dot here. This is on the speed arc, or on your arc representing true airspeed. And this, I want to stay on course, so I want this vertex of the triangle to be aligned on this extension. So again, you can move it around, fine, little fine adjustments, then tape it. Take some Scotch tape and tape it down there, because, well, we're just going to work from here and get all our answers. Our wind correction angle, we can see clearly we have to turn to the right. I'm going to have to turn my aircraft to the right like this. I'm aiming for this point, a little bit less there, and that's going to help me track correctly. Oops, moved the wrong one. But how much? Well, let's measure it. I'm going to draw, say, this little ray from here to there. Now, I can pull out my good friend, the protractor, and I could measure it this way. And let me see, that's 5. This is 10. This is looking a bit like 8. I could line it up that way, or I could spin it all the way around. I could measure this way. This way it looks a little more like 9. Well, 9, or is it 8? Yeah, I'd say that looks like 8 degrees. So it's going to be 8 degrees to the right. Let's move our protractor out of the way. And now, well, I guess I can, now let's figure out the heading, sure. Looking at, well, my compass rose, if I have to turn to the right, I'm going to have to be increasing the numbers. So 253 plus 8 degrees, that's true course, plus my wind correction angle. My heading is going to be 261. So 261 for my heading. And finally, ground speed. All we've got to do is line up our straight edge right there, and we're going to measure. Let's see, 90. That's 100. This is 110. So it seems like it's between the 8, the 6, and the 8. So I'd give that a solid 107 knots of ground speed. So there you go. Make sure you've got this. You've got these triangles cut out, taped down, and make all these calculations. And then we're going to confirm it with our good friend, the E6B flight computer.